Imagine a breathtaking aerial shot of a skyscraper that seems to defy gravity, its sleek form twisting impossibly towards the sky. The camera zooms in, revealing intricate structural details. Welcome to a world where architecture challenges the very laws of physics. Today, we're exploring buildings that push the boundaries of what's possible, structures that seem to float, twist, and dance in defiance of gravity itself. Get ready to have your mind blown by the ingenuity of human engineering and design. Cut to a 3D rendering of the Leaning Tower of Pisa, with stress lines visualized across its structure. Let us start with an architectural icon that has been puzzling visitors for centuries. The Leaning Tower of Pisa. This medieval marvel stands at a precarious angle, seemingly ready to topple at any moment. But how does it manage to stay upright? The secret lies in its accidental design. As the tower began to lean during construction, engineers made subtle adjustments, creating a slight curve in the structure. This curve, combined with the tower's low center of gravity, allows it to distribute weight in a way that keeps it standing, despite its alarming tilt. Transition to a series of floating buildings, their reflections shimmering on water surfaces. But what if we could make buildings that don't just lean, but actually float? Welcome to the world of floating architecture, where entire structures are built on water. These marvels of engineering use advanced buoyancy techniques to create stable foundations on liquid surfaces. Take the Makoko Floating School in Lagos, Nigeria, for example. This 3-story structure sits atop a platform of 256 plastic drums, allowing it to rise and fall with changing water levels. It's not just a building. It's a blueprint for how coastal communities can adapt to rising sea levels. Animated sequence showing a building swaying during an earthquake, with force vectors. Now, let's shake things up. Literally, in earthquake-prone regions, architects have developed buildings designed to sway with seismic forces rather than resist them. These structures use advanced damping systems and flexible materials to absorb and dissipate energy from earthquakes. The Taipei 101 skyscraper in Taiwan is a prime example. It houses a massive 728-tune pendulum suspended between the 87th and 92nd floors. During an earthquake, this tuned mass damper swings in the opposite direction of the building's movement, counteracting the seismic forces and keeping the structure stable. Transition to a bird's-eye view of Beijing's National Stadium, aka the Bird's Nest. But what if we could design buildings that don't just withstand nature's forces, but actually mimic them? Welcome to the world of biomimetic architecture, where designers look to nature for inspiration. Beijing's National Stadium, nicknamed the Bird's Nest, is a stunning example of this approach. Its intricate lattice of steel beams mimics the structure of a bird's nest, creating a form that's both aesthetically striking and incredibly strong. This design allows the stadium to distribute loads efficiently across its entire structure, much like a real nest. Cut to cross-section view of a modern building with termite mound-inspired ventilation system. Nature's ingenuity doesn't stop at structural design. The Eastgate Center in Harare, Zimbabwe, takes inspiration from termite mounds to create a passive cooling system. Just as termites regulate the temperature of their nests through a series of vents and tunnels, this building uses a system of chimneys, fans, and open spaces to maintain a comfortable temperature without air conditioning. Animated sequence showing tree roots growing, transitioning into the foundation of a skyscraper. Even the humble tree root system has lessons for architects. The deep spreading roots that anchor trees have inspired new approaches to skyscraper foundations. The Shanghai Tower, for instance, uses a system of deep piles and a broad base to distribute its enormous weight, much like a tree, spreading its roots for stability. Transition to underwater scenes, revealing futuristic submerged structures. But why stop at building on land? As we look to the future, architects are dreaming up ways to inhabit even the most extreme environments. Imagine checking into an underwater hotel, where your room offers panoramic views of marine life. The Poseidon Undersea Resort in Fiji is set to make this a reality. This ambitious project will feature 25 suites submerged 40 feet below the surface, with transparent acrylic walls offering guests an immersive ocean experience. The challenges of building such a structure are immense, from maintaining water pressure to ensuring guest safety. But the potential for unique experiences is equally vast. Aerial view of a floating city concept, with modular structures interconnected on the ocean surface. As sea levels rise, some visionaries are proposing entire floating cities as a solution. The Oceanic City concept, developed in collaboration with the UN, envisions a modular system of floating platforms that can be combined to create communities of up to 10,000 people. These cities would generate their own power, manage waste, and even grow food, offering a glimpse of how humanity might adapt to a changing climate. Transition to a space station rotating slowly against a starry background. But perhaps the ultimate challenge for architects lies beyond our planet altogether. As we look to colonize other worlds, we'll need to create habitats that can sustain human life in the harshest environments imaginable. One concept for space habitats involves massive rotating structures that use centrifugal force to simulate gravity. Imagine a cylindrical space station, kilometers in length, spinning slowly to create Earth-like conditions on its inner surface. Here, colonists could live, work, and even farm under artificial skies, protected from the vacuum of space by layers of radiation, shielding. Final montage of architectural marvels, from ancient wonders to futuristic concepts. From the Leaning Tower of Pisa to rotating space habitats, the story of architecture is one of constant innovation and daring vision. As we face new challenges from climate change to space exploration, architects and engineers continue to push the boundaries of what is possible, creating structures that not only shelter us but inspire us to dream bigger. The buildings of tomorrow may float on water, sway with earthquakes, or spin in the depths of space. But one thing is certain: they will continue to defy our expectations, challenging our perceptions of what architecture can be. As we look to the future, we can be sure that the most impossible-seeming buildings are yet to come. Fade to black, with the sound of construction gradually giving way to the quiet hum of a space station.